Yes, good morning students. देखिए yes, we are discussing about the gravitational potential. We have calculated the gravitational potential for a point mass. Yes. The next one we will calculate the gravitational potential for a spherical shell. So give the heading. Gravitational potential for spherical shell. Spherical shell we have done for spherical sphere heading देंगे for solid sphere. If we calculate for the solid sphere, this is a solid sphere. And let's suppose the mass m is filled in it, having radius capital R. From the center, I have taken the 3 points. This is a point A. This is a point C. And you can easily see this thing. Its radius is capital R. And its distance from there is RA. And distance from there is RB. And this distance is RC. Right? So if we want to calculate the potential at point A, that is point A. That is the outside point. Point A की क्या definition है here? RA is greater than capital R. We can consider whole mass at its center, which gives the potential at A is equal to, that is minus Gm by Ra. Point B, that is Rb is equal to R. So we can say this thing. For it also, we can place whole mass at its center. So, Vb is also equal to minus Gm by R. Now at point C, if we want to calculate at point C, point C, RC less than R. We can here potential at C is calculated in a different way by taking work done from infinity to C. देखो मैं इसको कैसे कैलकुलेट कर सकता हूँ. Now potential at C is the work done by agent from infinity to C. This is what? This is negative of work done by field from infinity to C. So you can say work done by agent from infinity to C is agent from infinity to B from B to C, and it gives potential at C is work done by agent from infinity to B is potential at B plus work done by agent from B to C. This is negative of work done by field from C to B. Now, what is the work done by field from C to B? So you can take any at X point. You will take a distance here, a point that is at distance X from there. And take a distance X, dx. What is field at this? What is the field at X? So field at X distance, it will become G m dash by X square. M dash is mass in this, so that will become G by X square, that is m by 4 by 3 pi r cube. Into X. X cube. That will become what? G by X, G by R cube into X. So what is the work done? dW. The field is in this direction, EX, and dx is in this direction, that is minus of EX into dx. What is this? Gm by R cube X dx. If we want to calculate the total work done by field from this to this, C to B, that is RC to RB, that is capital R, that is X dx, that is RC to RB. X dx is X square by 2. That will become minus Gm by R cube X square by 2. That will become RB square by 2. RC square by 2. RB is equal to capital R. So what is the potential at C? That is potential at B. The work done by field from C to B. This this is basically work done by agent from B to C. So it is negative of work done by field from B to C. या फिर negative of work done by field from, या positive of work done by field from C to B, because we have taken all the things reciprocal. So this is negative of field from C to B. So what is this? What is VB? Minus GM by R. If we multiply it, take this negative sign there, that will come out to be minus GM into by 2R plus GM into RC square by 2R cube. That will become minus 3 GM by 2R plus GM into RC square by 2R cube. That is the potential at point C. If RC is 0, potential at origin, at center will become minus 3 GM by 2R. Minus 3 GM by 2R. Right? So here, if we draw the plot, for V versus R, that is minus GM by R. So here it is minus GM by R at R is equal to capital R. After that it will go like this. Till there it is like this. So it is the variation. This is at R is equal to 0. Right? So it is the thing. So it is the potential due to the solid spherical shell. Yes, write down the question. Calculate potential due to two concentric shells having masses m1, m2 and radii r1, r2. at point P as shown at point P and Q as shown in figure. There are two concentric shells. So it is its center. And this is having mass m1. The radius is r1. Body radius is r2. Its mass is m1 and its mass is m2. The P point is this point, having radius rp. Q point is this point, having radius rq. So potential at point P is, due to it is m1 plus m2 both, so what is due to m1? For m1 it is the outside point, so it will become minus g m1 by rp. For m2 it is the inside point, so it is minus g m2 by r. What is r? r2. And what is the potential at point Q? Point Q is the outside point for both, so it will become minus g m1 by r and minus g m2 by rq. So it is the potential due to both. Basically at point P, we have to calculate potential at point P and Q. And we have to calculate the potential at P due to both masses. Like P point is the point that is lying in between the two shells. So for M1 mass, it is the outside point, and for M2 mass, it is the inside point. So for M1 mass, it will become G M1 by, this is Rp. And for M2 mass, it will become G M2 by, this is R2. Right? जो उसके surface पे है. So if Q we will taken, the Q is the point which is located outside it, and here it is G minus G M1 by RQ, and for this it is minus G MP by M2 by RQ, right? So this is the system. Next, calculate gravitational potential of given system at point P as shown in figure. And what is a given system? Basically, it's a disk. Basically, it's a ring. We have to calculate the gravitational potential at a distance 4r point P. The ring is having the mass m and radius r. You will take it is a disk. It is a disk of mass m and radius r. P is the point lying on its axis. X is at a distance r. This is the distance r. Yes. So what is the potential at point P? This is a disk. देखो इसको करने का तरीका क्या है? First of all, you just cut at a distance x. Cut a ring of dx. If we take this dx, its distance from this mass is, it is same. How much is this distance? If I am taking dr, so what is पहले dm? dm is the mass of the ring that we have cut. That is m by pi r square into उसका radius, उसका area. That is 2 pi x into dx. Right? So what is molar? Under root of x square plus 4r into whole square. So potential at point P, that is GV, it is due to x, we are rating due to dm. So dm by, it is at a distance, constant distance smaller, the whole mass. So minus of g into dm by smaller. That is minus of g into dm by small r. And what is r? R is this much. It will become minus g into dm. What is dm? dm by this. That is 2m by r square into x dx divided by r. R is under root of x square plus 16r square. Integrate this, if we calculate the total potential at this. That is minus of g into m by r square. Integration of x dx by x square plus this. X is varying from 0 to capital R. If we consider x square plus 16r square is t. So if we do d by dx of this, so it will become 2x into plus. It's constant, it is gt by dx. So x dx is written as dt by 2. So the integration will convert into that is the potential will come out to be minus 2 into gm by 2 एक मैं मल्टीप्लाई कर रहा हूँ 2r स्क्वायर इंटीग्रेशन में बन जाएगा 2 into x dx. If 2 into x dx को मैं क्या लिख सकता हूँ, ये x dx को मैं क्या लिख सकता हूँ, dt by 2 and this is root t. t तो बाहर निकलेगा, 2 तो बाहर निकलेगा, 2 कट जाएगा. It is minus gm by r square integration root t, t raised to power 1 by 2. That is 1 by 2 plus 1 divided by 1 by 2 plus 1. That is t raised to power 3 by 2 divided by 3 by 2. Minus 1 by 2 plus 1. That is t raised to power 1 by 2 divided by 1 by 2. So 1 by 2 into root t. And what is t? X square plus 16r square. Where r is varying from what? X is varying from 0 to capital R. That will become what? Potential will become minus gm by r square. If we put x is equal to capital R, that will become what? R square plus 17 r square. That is root 17 by 2 into r. and this will become 0, that is 4r. This r and r will cancel out 1. That will become minus gm by 2r root 17 minus 16 minus 8. So this will give what? Potential at point P. Is it right? So this is the value of the potential in this case at point P due to this whole disk. Is it clear? लिख लो इसको. Yes, next. Next, give the heading relation between gravitational field and potential. Gravitational field is a conservative field. So, work done by gravitational field is used to cause change in potential. Change in potential. We know this thing. The change in potential, it is negative of work done by field. That is minus of E dot ds. First thing is this. But if we calculate change in potential, so you can integrate this. Okay. Delta V is minus of integration of E dot ds. That is, from this you can get, here we can derive change in potential from field. P from potential function. Now we can write E is equal to minus dV by ds. You can judge from there. dV is equal to minus E dot ds. If we will take E is equal to Ex I cap plus Ey j cap plus Ez k cap, and ds is equal to dx I cap plus dy j cap plus dz k cap. Then we will get dv is equal to minus of ex into dx minus ey into dy minus of ez into dz. Now y and z is constant. Px is minus dv by dx. यहाँ पे y z के constant, or you can write it is minus del v by del x. dy is minus del v by del x, and ez is minus del v by del z. Here E will become equal to, that is Ex I cap plus Ey j cap plus Ez k cap. Ex will come out to be minus del v by del x I cap minus del v by del y j cap minus del v by del y k cap, del y by del z k cap. So this is the thing. Is it clear to all of you? So in this way we can derive the relation for the gravitational field from the gravitational potential function. That is by taking these partial differentiations, that is del v by del x, del v by del y, or del v by del z. In this way, right? Like write down the problem on it. Calculate potential at point 2,3 due to gravitational field given as E vector is equal to 2x I cap plus 3y square j cap. such that at origin gravitational potential is zero. Now we know this thing, the change in potential is minus of E dot ds from initial point to final point. So change in potential is negative of initial point to final point is 0,02, 2,3. E dot ds करेंगे it is ex I cap plus ey j cap and this dx I cap, that will become 2x into dx plus 3y square into dy. Integrate it and put the limit of x and y separately. That will become x square by 2, 2 से 2 cancel हो जाएगा. That is 0 to 2 plus. There is a minus sign outside. Minus of this, minus of this. 3y, y cube by 3, 3 से cancel हो गया y cube. That is 0 to 3. That will become minus of x square. 2 put करेंगे तो minus x square is 4. That is change in potential. So delta V will become, that is minus of 31 joule per kg. This is what? V final minus V initial minus 31. V final is what? We have to calculate V initial is what? 0. V final is what? Minus 31 joule per kg. Is it clear to all of you? So I have calculated the potential at point due to the work done by the electric field, because it's a conservative force, a conservative field. Gravitational potential in a conservative field varies as 3x square plus 2yz plus 7xy. Calculate gravitational field vector due to it at a point 2,3 0. Gravitational. Now we have given the potential function. What is the potential function? So V is equal to given 3x square plus 2yz plus 7xy. Now what is field? That is minus del V by del x I cap minus del V by del y j cap del z k cap. What is minus del V by del y? Differentiate it with respect to v, with respect to x, keeping y and z constant. So del v by del x. Y and z is constant, so this is constant is 0. With respect to x, it will become 6x, and with respect to x, it will become 7y. That is minus of 6x plus 7y. What is minus del v by del y? With respect to y, this is with respect to y is 0, and this will become 2z, and this will become x is constant, 7x. With respect to z, so with respect to z, it will become 0, it will become 2y, and this will become constant is 0, so this will become 2y, and with respect to z, it will become also 0. Now if we put the values at 2, 3, 0, Ex will come out to be minus del v by del x, that is 2 and 3, x को 2 put करेंगे, 6 into 2 is 12, y को 3 put करेंगे, 7 into 3 is 21, 21 plus 12 is, that is 33, that is minus 33. Ey is what? x को 2, y को 3, x को 2 put करेंगे तो 7 into 2 is 14, y को z को 0 तो 14 ही बचेगा, तो minus 14, and z को ये put करेंगे तो x को put, y को put करेंगे 3, तो 2 into 3 is 6, तो minus 6. So E will come out to be, that is minus 33x I cap, minus 14j cap, and minus 6k cap, right? So it is a gravitational field due to the potential function given here. Is it clear? Yes, next. Next is gravitational potential energy. Gravitational potential energy, right? देखो इसको हम कैसे डिफाइन करेंगे? For 2 point masses, लेट्स सपोज एक बड़ा मास है कैपिटल एम, उससे r डिस्टेंस पे एक मास है स्मॉल एम. We have to calculate potential energy. Potential energy of the given system is the work done to carry small m mass from infinity to given point in the presence of capital M. Right? So it will come out to be what? That is the potential energy. That will come out to be small m into work done to carry unit mass. That is the potential at point P. So U will come out to be minus G capital M into small m by R. Potential energy of the two particle system. Is it clear to all of you? So it will become the potential energy of the two particle system. That is the thing. Is it right? Write down it, please.